Hello everyone, myself Varsha Bodade from Department of Information Technology, Terana Engineering College, Nerul, Navi Mumbai. This video is for clarifying the doubts raised by the student during NPTEL video which I have posted in my WordPress website under the topic Analog Modulation from subject Principle of Communication Engineering. This video gives a brief idea about amplitude modulation type DSB-SA. So let's start with the basic which he has covered. So first, what is communication? So it is a process of conveying message or information. Transmitter modifies the message signal into a form suitable for transmission over channel which is achieved by modulation. Then he has covered what is modulation, need of modulation, types of modulation, advantages of modulation, and he has given in brief what is analog modulation DSB-SA, its representation in time and frequency domain, and at last he has given just an introduction of demodulation. So let's see what is modulation. So the process by which some characteristics of carrier varies in accordance with the instantaneous value of information signal, that is modulating signal, is called as modulation. So analog modulation, it is a continuously varying sine wave is used as a carrier wave that modulates a message signal or data signal. The sinusoidal waves parameters can be altered to get modulation. They are the three parameters, that is amplitude, frequency and phase. So the types of analog modulations are amplitude modulation AM, frequency modulation FM and phase modulation PM. So AM, amplitude modulation. So in it, only amplitude of the carrier wave is varying as per the message signal and the other factors like frequency and phase remains constant. This type of modulation requires greater bandwidth, more power. Filtering is very difficult in this type of modulation. Types of AM signal. There are 5 types of AM signal. DSB-FC, double sideband full carrier, DSB-SC, double sideband suppressed carrier, SSB, single sideband, VSB, vestigial sideband, ISB, independent sideband. So here we have to see DSB-SC, that is double sideband suppressed carrier in detail. So let's see what is DSB-FC. So transmission of a signal which contains a carrier along with two sidebands can be termed as double sideband full carrier system or simply a double sideband FC or DSB-SC. Its plot is given in the figure, that it contains a carrier and two sideband. So let's have a reflection spot. Why DSB-SC? So here, however, such a transmission is inefficient because two-thirds of the power is being wasted in the carrier which carries no information. If this carrier is suppressed and the saved power is distributed to the two sideband, then such a process is called as double sideband suppressed carrier system or simply DSB-SA. Its plot shown over here, that there are two sideband, upper sideband and lower sideband, whereas the carrier is fully suppressed. Now let's see how we can get the double sideband suppressed carrier. So for getting double sideband suppressed carrier, we have to use a principle of multiplier. So this multiplication is offered by a mixer. So here we require two signal. One is the message signal and other is a carrier signal which is multiplied by a mixer, and after multiplication we are getting a modulated output. So AM, amplitude modulation, in that DSB-SC, double sideband full suppressed carrier, it gives the basics of this, that it gives frequency translation. The other name for it is mixing or it is heterodyning. So here this is the message signal, this is the carrier signal. After multiplying, this message signal gets multiplied by a carrier signal, and here we are getting a modulated output. So the modulated output is nothing but the envelope, and it will be equal to A mt cos omega ct. So after modulation we are getting xt is equal to A mt cos omega ct. This mt is the message and this is the carrier. So this message gets multiplied with the carrier, and in the output we are getting the carrier is fully suppressed. Now the first question raised by the student is that why there is a phase reversal at zero crossing. So this is the message signal. After modulating, we are getting this is a modulated output. This is called as an envelope. So envelope is nothing but a trace of peaks, and this envelope is directly proportional to A into modulus of MT. So this is the message signal. This is the message signal, and the modulus of this message signal is the envelope. So this is the modulus of the message signal. Therefore, MT, this MT just before zero crossing is gets multiplied by a positive quantity. Let's say T dash. So it will be equal to cos omega C T dash. And just after zero crossing, this message signal gets multiplied by a negative quantity T dash minus. So it will be equal to minus omega C T T dash. So here we can see that this is positive and this is negative. So it experiences 180-degree phase shift at zero crossing. So that's why over here we are getting a phase shift of 180-degree. So the second question raised by the student is that he is asking that whether we have to assume that the frequency of message is the multiple of carrier omega ct. So answer is that such assumptions are not required. It will always happen at zero crossing. This property it will hold. I hope I have tried my level best to clarify the doubts. Thank you for your patience listening. Have a good day.